All right, everybody, this will be a solution to the collision detection problem that we've been working on. Here's the situation. T-Rexes and cactuses we're both displaying as images, and each image is a rectangle. So mathematically, the problem that we want to solve is we need to figure out a test that uses the coordinates of the two rectangles to figure out whether or not the two rectangles are overlapping each other. There's a lot of simple tests that we could use that would probably be good enough for this game, but I wanted to look at a more general test we could use that will work no matter what shape and size the rectangles are. And here was the idea of that test. Here's an example of two rectangles that are overlapping. Here's two rectangles that aren't. What we're going to do is we're going to look at the shadow that they cast if you look at the intervals on the x-axis that they cover and the intervals on the y-axis that they cover. So we're going to say that the big problem of whether or not they're overlapping is going to break down to the question of whether or not their shadows overlap. So here we see that on the x-axis, the two intervals overlap, but on the y-axis they don't. And that means that the two rectangles aren't overlapping. Here they overlap both in the x-axis and in the y-axis. So coming back to our picture of the T-Rex and the cactus, inside T-Rex, we're going to provide a method called isCollidingWithCactus. Maybe we should just call it isColliding, where we give it a cactus as an input. We want to ask the question, are there x-interval shadows overlapping, or are there y-shadow intervals overlapping? So if we only had this method called isIntervalOverlapping, then we could get the T-Rex's x-coordinates and the cactus's x-coordinates and ask the question. And then we could get the T-Rex's y-coordinates and the cactus's y-coordinates and ask the same question. And we'd say if the x overlap is true and the y overlap is true, so if both of these questions, the answer was true, then our method of answering whether they're colliding will also return true. So how are we going to do that? Our isIntervalOverlapping method is going to take 4 inputs. It's going to take the coordinates for the start and the end of the first interval, and the start and the end of the second interval. The first interval, I don't mean the leftmost one. I just mean whichever is the first interval that we're looking at. So we might have a situation where the second interval happens before the first interval, or it could be the other way around, where the first interval happens before the second interval. All right, so the question is, how's this method going to work? We need a test that will tell us, no matter what the situation is, are they overlapping or not? So I've done a couple of examples. This doesn't exhaustively list all of the possible ways the intervals could look. But this is part of what makes the problem tricky, is we have to make sure that the method is going to give us the right answer no matter what the input coordinates look like. Sometimes it's easier if you test for the opposite of the thing that you're actually interested in. So here I want to know if the intervals are overlapping, but there's lots of ways the intervals could be overlapping. Like they could be one interval's inside the other one, or they're partially overlapping this way, or what if these were reversed? They could be partially overlapping the other way. I think maybe it's going to be more straightforward to test for whether or not they're not overlapping, test for whether they're separate. Because if I think about it, there's really only 2 different ways the intervals can be separate. Either the start of the first interval happens after the second one, or the start of the second interval happens after the first one. So those are the 2 conditions that I want to test for. So let's jump into the code and start doing this. Here I am in T-Rex, and I said that I wanted to make a method that returns true or false called isColliding. And I need an input that's whatever I want to know what it's colliding with. So I'm interested in cactuses right now, so I'll take a isColliding method, input cactus, which I'm going to call C. And then remember we were going to do 2 methods. I was going to say isIntervalOverlapping for an x interval, and the same thing for a y interval, isIntervalOverlapping. And these still need inputs. I'm leaving that part out for the moment. And then I'll say if x interval is overlapping and y interval is overlapping, then I'll return true. Otherwise, I'll return false. It might be easier for you to think about if you actually put in the equals true here. So if they're overlapping in both intervals, then that means overall the Trex rectangle is overlapping the cactus rectangle. All right, so we obviously need to write this method. I guess let's do that right now. So I'll make this private because I don't want anyone else to run it. I only want to run it from inside Trex. And it's called isIntervalOverlapping. And I'm going to take several inputs. I'm going to take the start of interval 1 and the end of interval 1 and the start of interval 2 and the end of interval 2. And I said that there's really only two ways that the intervals can be separate from each other. If the start of interval 1 is larger than the end of interval 2, then I know we're safe. They're not overlapping. Or if the start of interval 2 is larger than the end of interval 1, I also know they're not overlapping. So in both those cases, I would return false because they're not overlapping. Otherwise, I would return true because they are. Okay, so hopefully that works. So now I just need to figure out how do I give it the right inputs here. So let's look back at the picture and think about it for the x intervals. I'm going to ask my Trex what its left side x-coordinate is and what its right side x-coordinate is, because that's the first interval that I want to ask whether it's overlapping. And then I'll do the same thing for the cactus. For the cactus, I'll say, what's your x coordinate and what's your right side x-coordinate? So when you're programming, you're often in a situation where you need some information and you're not sure where to get it from. So here, let's write all this down so that we can keep it clear in our heads. So I need the Trex left side x, I need the Trex right side x, I need the cactus left side x, and I need the cactus right side x. All right, I'm going to try and get each of these things. And I'll just put them in their own variables right now. So Trex left. Okay, so where do I get the Trex's left side x coordinate? Well, I'm inside the Trex class right now, and if I look at the variables, Trex has an x-coordinate, and the x-coordinate happens to be the left side of the Trex. So that one I've got. I can just assign the Trex's x-coordinate to be the Trex left x. All right, how do I get the Trex right side coordinate? Well, that's going to be its x plus whatever its width is. So let's see. It looks like I don't have a width variable. Oh, but I have this method called getWidth, which returns the width of the image that I'm displaying as. So let's use that method that I already have. I'll say getWidth. And I know that the left side x-coordinate plus my own width should give me my right side coordinate. All right, so far so good. So I've got those two. Let's do it for the cactus. So the cactus I'm interested in is this one that got passed as an input, and it's called C. So let's see what I can do here. So cactus left equals C dot. I like to see what methods I have available because maybe I have a command that's already built into cactus that does what I want. So let's see. Blah is off screen to left, draw, blah, blah, blah. Okay, doesn't look like it. So if a cactus doesn't already have a command that does what I want, that means I have to make one. So let's think. What do I actually want? Where were we? Here we are. So I actually want to ask the cactus what its left side x-coordinate is. So I'm gonna pretend there's a method called getLeftX for getting the left-hand x-coordinate. And it's underlined in red because it doesn't exist yet. So let's make it in cactus. Let's see, public something, get left x. So what's this supposed to do? It's supposed to return the coordinate, the x-coordinate of my left-hand side. Okay, the phone rang and I forgot what I was saying. All right, so I'm trying to get the left-hand x-coordinate from my cactus. So what am I going to return? I guess I'm going to return my cactus's x-coordinate. That makes sense. Cactuses have an x. Ooh, let's make them float. So what that means is the data type I'm returning is float because the data type of the variable that I'm being asked about is a float. All right, so this is a weird way of thinking if you're not used to it, but remember the idea is these objects have information about themselves. Sometimes a different object needs to get that information. So here a cactus has an x-coordinate. My T-Rex needs a way of asking the cactus, what is your x-coordinate? So the way that we let that happen is inside cactus, we create a command called getLeftX, which now somebody else can use to ask the cactus a question. What is your x-coordinate? And when the T-Rex does that, the cactus will return its own variable, and now I can use it over here in T-Rex. So let's do the same thing for the right-hand one. So float cactus right equals c.getRightX. Just like we did before, let's make a command that will return the cactus's right-hand x-coordinate. So I'm going to return x plus getWidth. Okay, so it looks like a cactus does not have a getWidth method, so let's make one. Just like last time in the T-Rex, the cactus has an image called img. You can double check it up here. Here's the cactus image. So the width of the cactus is the same thing as the width of the image. So if someone wants to know what's the width of the cactus, I'm going to give them the answer to the question, what's the width of the image? All right, so backing way up now, our whole goal here was to figure out what's the left and right-hand sides of the cactus and the T-Rex. We couldn't do that before because we needed to create some commands that would let us ask the cactus what its coordinates are. We've done that, so now we have all the variables we need, and I think we can start filling them in. So T-Rex left, T-Rex right, cactus left, and cactus right. And now we'll use our interval overlapping method to ask the question whether the intervals are overlapping. You should do that same thing for all of the y coordinates now. Okay, so I've done all that. Now it's time to actually use that command that we just made. So let's see, how many, all right, so I've got my cactuses in an array list here. So let's go to my draw method. All right, here's the loop where I'm looping over my whole cactus list. I'm getting out each cactus one at a time and saving it inside a variable called c, and I'm telling it to move and draw and all that. So at the end of this, I'm going to take my T-Rex, and there's only one of those, and I'm going to say if T-Rex dot is colliding with the cactus c, so if that's true, if they're colliding, well, I'd probably want to do something like change how the T-Rex displays and do some other stuff. But just to make sure it's working, I'm going to display a print statement just so I can see what's going on here. Okay, be careful. Don't get deceived into just copying down the code that I'm writing. Think carefully about what's happening. So the reason I wrote C right here is because C is the variable that's holding each of my cactus objects as I loop through this loop. So all of my cactus objects are in a list, and I'm visiting each location in the list. And every time I get a cactus out of a location, I'm saving it here. I could have called this something else, and in fact, I'm going to right now. I'm going to call this cactus Marlowe. So now I'm asking Marlowe to move left, and I'm asking Marlowe to draw, and I'm asking my T-Rex, are you colliding with Marlowe? And each time I go through the loop, Marlowe is going to be a different cactus. All right, so let's see if it works. So here I am running. Why is my cactus not moving? Well, it's a whole other kind of problem. Okay, so when I'm running the game, it looks like, cool, so I see ouch happening when I'm overlapping the cactus. Okay, let me jump. Cool, so I jumped over that one. Oops, and there I hit it. All right, so it seems like it's working. Some people are noticing that ouch is happening even though it looks like I'm escaping the cactus. And remember, the reason is because we're using the entire rectangle, not actually the image of the cactus. Not the part of the image that we can see anyway. So if you want really pixel-perfect collision detection, that's going to be a little bit trickier, and we can do it, but let's wait for a later video for that one. Okay, I hope this has been helpful. Good luck.